Algebra 1, Post-Chapter 10 Worksheet number 4, the last of 4 worksheets that we'll be doing. And again, you should have Worksheet 4 printed out and do this along with me. Unlike the previous video, I think we'll be doing 5 of these total, so there will be a significant amount of these that I think you can do yourself pretty quickly. I will at the same time hopefully make it a shorter video. Looking at, first of all, before we look at 1, 2, etc., I think I'm going to do 1, 2, and 6 on the front side of this worksheet. Before we look at that, there's one kind of simple thing that maybe you've already picked up in things we've done previously. If not, I'd like to put together some things that we've talked about. And basically, it says this: if x minus a is a factor, then a is a root. If x minus a is a factor, then a is a root. This leads somewhere very significant that you learn about in Algebra 2 called the fundamental theorem of algebra. And it's kind of a simple fact. And again, if you haven't thought about it in these terms, let me make sure you understand. This a right here stands for a number. This is the article a, right? So it's just is a factor. Then a, same number, is a root. So if x minus, let's just pick a number, if x minus 2 is a factor, then 2 is a root. Or as an example here, if x minus 3 is a factor, then what would go here to show you that it's a root, to express that it's a root? And that would be 3. Or how about x plus 14? Think about that for a second. If I told you that x plus 14 were a factor of some polynomial function, then you could tell me what root would correspond to that. And that would be negative 14, of course, because this x minus a, and here we have x plus 14, that should be interpreted as x minus negative 14. Okay? So that's the relationship, and that's really what we got to at the heart of the worksheet that was the previous one, worksheet number 3, that there is this relationship of factor and root. And one of the main ideas anyway. Okay, what about this question? What if you know that 6 is a root? Rather than being given the factor and you find the root, what if I told you that 6 is the root? Well, you should be able to conclude that x minus 6 is a factor. Now, it's easy enough to just look at this and go, okay, it's x minus whatever the number it is. And that's true. It's x minus whatever the number is. But the better way to see it, the way I would have you to see it, is that 6, when I plug it in here, would cause this to be 0. Right? It's a 0 on the graph. It's a root of the function, if you understand the relationship there. So 6 would cause this to be 0. This is where it's going to cross the x-axis, right? Because that would be where the the y value is 0. If 6 causes this to be 0. By the way, if it's x minus 6 and we plug in a 6, it doesn't really matter what else you have here, whether you have 1, 2, 3, or 10 other factors. If I plug in 6 here, this becomes 0, and then whatever else you're multiplying by doesn't matter because it's getting multiplied by 0. That causes the function to be 0 there, okay? And that'll become evident when we do some of the worksheet, as we're going to do right now. Okay, so looking at number 1, when they tell me that the zeros, now again, 0 means we're looking at a graph, and the zeros would be 5, negative 1, 3 would be where that graph crosses the x-axis. These are the x-intercepts. Okay, so when we graph y equals whatever this thing is, its x-intercepts are 5, negative 1, and 3. However, if we were solving that same equation, not y equals that thing, but rather 0 equals that thing, and we were solving for it, we would solve and we would get these 3 numbers, 5, negative 1, and 3. And that should come clear with what we did in Chapter 10 when we were solving by graphing. We graphed the parabola is what it was back in Chapter 10, and wherever it crossed the x-axis, those were our solutions. Okay, that's what we're talking about here. But there's 3 of them, and it's 5, negative 1, and 3. So we want the equation in factored form. That would be y equals, and then x minus 5 times x minus negative 1. Make sure you change minus negative to plus, times x minus 3. Just using that simple fact that I showed you on the previous slide. X minus 5, x minus negative 1, x minus 3. Okay? Now, that has a degree. We've talked about degree as well. If you multiplied this whole thing out, wouldn't you have a x cubed as the first term? So the degree is 3. okay? And that then leads to how many directions there are on the graph. This is going to be something that goes up, down, up, up, down, up. Now, could it go down, up, down? Sure, it could go down, up, down. But here's a quick little test. Think of two numbers that add up to 3. Real quick, do that. Think of two numbers that add up to 3. Now, I would guess that most people thought of 1 and 2. Those are the simplest two numbers that you can think of. Could somebody have thought of negative 1 million and positive 1 million and 3? Or could somebody else have thought of negative 1 and positive 4? Sure, but the easy thing to come up with right away is 1 and 3. So I'm not going to make up anything more difficult and put a negative here or some kind of multiplier. You know what? If I did, it would still have these 3 zeros. But why would you do that? So in this case, as we discussed in the previous, on the previous worksheet, it's going to be up, down, up, because the lead coefficient would be a positive number, positive 1 in this case. Okay? Now, where would it cross the x-axis? Well, we already know that. The zeros are in numeric order, negative 1, 3, and 5. So I'll make a tick mark here at negative 1. 1, 2, 3 would be here. 4, 5 would be here. These are the 3 places where this graph is going to cross. Now, what we don't care about on this particular worksheet that we'll make a bigger deal about next year in your Algebra 2 class is how high you go on these. So I don't care. All I care is that you know that it passes through these 3 points, something like this. And do put arrows on it, because that shows me you know that the function continues in the 2 directions. But how high is it? We don't really care. How low is this? We don't really care. I do want to show you that on a calculator real quick. I have it typed in already. Here's the function that we just said. I have only the first one highlighted here, so that's all you'll see. And I have it set on an appropriate window. And there's the graph of it. And in your Algebra 2 class, you will get the ability to trace. So if you wanted to know how high it is, you could kind of get close by doing this right here. We actually have a way of getting there more exactly. This is called a relative maximum. You might notice that the function maxes out here for this kind of local area, and it minimizes here for this local area. It doesn't have an ultimate maximum because this graph will continue up this way forever. And it doesn't have a minimum, total minimum here, like kind of like an ultimate minimum, because yeah, it's got a kind of a local to this general area minimum here, but ultimately it goes this way forever, down, 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 down. Okay, so it's what we call a relative maximum is this, a relative minimum is this. That's a topic for next year though. Okay, but that's how high it goes, roughly 17. Okay, if I wanted to go how far down this one goes, roughly negative 5. Okay, just about. We'll give you a better method for that next year. All right, moving to number 2. Let me let you think about that for a second. How many factors will there be? Isn't it 3? Because there's 3 zeros given. It's going to be x minus 1, x minus 7, and x plus 5. Make sure you change minus negative to plus. So once again, this is of degree 3. And if I just take those zeros, numerically, negative 5, then 1, then 7. So negative 5 this way is here, then positive 1, and then positive 7. 2, 3, 4, 5, 6, 7. And we got a function that does something like this. It's a cubic function. It passes through those 3 points, negative 5, positive 1, and 7. Okay, now I did graph this one also, just to take a quick look. I decided on a different window for this one slightly. I guess not slightly, that's quite different actually. We'll go by tens there. That just says that every tick mark is 10 vertically. And there's what that one looks like. Okay, now your graph may not look exactly like that because you don't know exactly how high and how low to go, but that's okay. We're not really focused on that anyway, but it does have zeros at negative 5, positive 1, and positive 7. Okay, now I'll leave the next few for you to do. Number 6 is a little bit different. Let's go ahead and do that one. Y equals, notice that it has 4 this time, x minus 2, x minus 3, x minus negative 3, so x plus 3, and then this would be x plus 1. X minus 2, I'm going to have to use 2 lines to just show this. X minus 3 times x plus 3 times x plus 1. Okay, 4 factors. Why 4 factors? Well, because there were 4 distinct zeros. Okay, that means that my graph is going to cross at these 4 points. And I just want to go in order again, -3, -1, 2, 3. Now, when they're an even function, wouldn't you know that if you multiplied this whole thing out, like you FOILed this, and then you FOILed this, and then you FOILed what you had left, or I guess it wouldn't be FOIL, you use the extended distributive property to multiply everything again and simplify. Don't you realize that you'd have an x squared, and then an x squared, and then when you multiply those two things, you'd have an x to the fourth, 1x to the fourth. So the lead coefficient would be 1 in standard form. That's a positive number, so this is going to open up. Okay. Again, I could put a negative here. That wouldn't affect things as far as the relationship of the 4 zeros that were given and the equation I came up with. But why would you do that? So this is going to open up. And it's going to look something like this. And again, we're not looking for anything close to perfection here, but just something that passes through those 4 points. So something like that. Now I wanted to show you this one also on the graph because it is going to look a little bit different than what I showed, just because the calculator can be more accurate than I can be. And there are some things about this that we're not teaching you yet today. You're getting somewhat of an overview lesson of a more in-depth lesson that you'll get in Algebra 2. The window I want to use is -5 to 5 and -50 to 50. We'll just leave the scale going by tens. So notice that it does cross the x-axis 4 times in the 4 places that we said. This relative minimum is lower than this relative minimum. Okay. You just hang on to all that information about minimums and maximums until like next October. Okay. All right. Flip the page over. Everything else that I didn't do, I'd have you to go back to do after you're finished watching this video. In number 9, it's essentially the reverse of what we just did. Now they're going to give us the equation, and we're going to say what the zeros are and what the degree is and what the leading coefficient is, and then we'll sketch the graph, okay? So look at this, and again, I'll just give you a second. There would be 3 zeros here. Don't you know that if you multiplied this whole thing out, it'd be x to the third, etc., right? So that's going to be third degree. The number of zeros would have to then be 3, then 3 as well. And they are, well, I think 2 of them are easy to identify and one of them is a little bit elusive. This would be 2. This would be -8. But wouldn't this also be 0? So I like to put them in numeric order if I can remember to do that. So how about -8, 0, and 2? That'll help me when I graph it. This right here is like saying x minus 0 in parentheses. We don't bother with the -0, therefore we don't have to bother with the parentheses, but that's what it means, and 0 in for x would cause that to be 0. So that's why you have to include 0 here. You know, 1 minus 0 would not cause that to be 0. 2, 3, 5, a million would not cause this to be 0. Only the number 0 does. So we need to include that. If you just said -8 and 2, that would be wrong. That would be something that seems more quadratic than cubic of degree 3. Okay? So those are the zeros, that's the degree. And then leading coefficient, please do pay attention to this. What would the number be? You know, you don't have to multiply this whole thing out to get what it would be, but you have to kind of envision what would happen if you FOILed these 2 factors and then distributed in an x. That would be x to the third. So the leading coefficient being the number in front of x to the third is 1. All right, and then we can just graph it because we figured out what the zeros are. Here's -8. There's 0, and then 2. And up, down, up. Do a better job than I am on my starboard here, but I'm trying as hard as I can to make it pass through those points. It's difficult. The next one, 10, shouldn't look unfamiliar to us at all. It's just quadratic, right? So 2 zeros, they are at 3 and -3. You see? 3 for this one, -3 for this one. It's quadratic. That means it would be of degree 2. The leading coefficient here would still be 1, and I can plot those points. Here's -3, here's 3, and it's a parabola. It's only crossing the x-axis twice. And the leading coefficient being 1, right? If I multiply this out, you get x squared minus 9 is really what this would be. So it's a parabola that's opening up. Something like that. Okay, and I think I'll leave the rest for you. Actually, let's go ahead and do number 12. One more thing. I think some people might be confused about number 12. This one's also quadratic. Okay, and I think most of the rest will be, well, looks like I see a couple quadratics still out there, a couple cubics, and maybe even a quartic. But anyway, we were going to do number 12, and there are two zeros, I should say, and one of them would be 8, and the other one, believe it or not, is going to be 0. 0 would cause this to be 0. 0 times -6 is 0. So you have two of them, and they are 0 and 8. The degree, again, would be 2. It's quadratic. The leading coefficient, this is why I picked this one. What would we put here? The leading coefficient is actually -6. Not just because it's -6 right here, but because in standard form, if we were to multiply this out, -6 times x is -6x squared, the number in front of the x squared being your leading coefficient. Okay? And here's 0 then. And 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. And the leading coefficient being negative, wouldn't this be a parabola that opens down? Okay, now again, for the purposes of this worksheet, the vertex is not even important to us as far as how high it goes. Of course, it would be at 4, right? 1, 2, 3, 4. The vertex is here at 4 comma something. And you could figure it out. In fact, you have the methods for figuring that out. It's just not important for the representations on these graphs. All right, that's all I have for you. Please finish what was not done, what we didn't do together. Thank you for tuning in.